Here we have x is a random variable and it has the normal probability density function. And we want to show that the variance of x is equal to sigma squared. And the variance of x is defined as the expected value of x minus mu. Mu is the mean of x squared, which is the same as the expected value of x squared minus the expected value of x squared. In an earlier video, we have shown that the expected value of x is mu, and so this is just mu squared. And so now what we need to find is the expected value of x squared. And so the expected value of x squared is just the integral from negative infinity to positive infinity with the integrand x squared times f of x, or times the PDF, the probability density function here. So we end up with x squared times 1 over the square root of 2 pi times sigma times z to the negative 1/2 x minus mu over sigma squared. Let z be x minus mu over sigma, so we get 1 over sigma times x minus mu over sigma. And then from here, solve for x. We get x to be sigma times z plus mu. The derivative of z with respect to x would be 1 over sigma. Mu over sigma is constant, so the derivative is 0. dz is equal to 1 over sigma times dx. And so multiply both sides by sigma, we have sigma dz is equal to dx. The expected value of x squared be the integral of x squared times this. X is sigma z plus mu, so in the place of x we have sigma z plus mu. Z is x minus mu over sigma, and so this becomes z. Multiply this out, we get sigma z squared plus 2 sigma mu z plus mu squared, and then times this. And now expand this integral. So first we have the integral of sigma z squared times this, and then we have plus the integral of 2 sigma mu z times this expression, and then last we have the integral of mu squared times this expression. One sigma squared and this should be sigma squared So here we have sigma squared times 1 over the square root of 2 pi, which is constant, so we can move the sigma squared times 1 over the square root of 2 pi and place it in front of the integral. 2 sigma times mu is constant, so we can move it and place it in front of the integral. Mu squared is constant, so we can move it and place it in front of the integral. Earlier, we have shown that the integral from negative infinity to positive infinity with the integrand z squared e to the minus 1 z squared, this is equal to the square root of 2 pi. And so see the description section for the video link. Earlier, we have shown that the integral z times e to the negative 1/2 z squared, we have shown that this is equal to 0. So see the description section for the video link. And then this integral right here, this is the normal probability density function in here, right here, with mean of 1, mean of 0, and sigma of 1. And so we have shown that this integral is equal to 1. And so see the description section for the video link. And so this and then times the square root of 2 pi, because this integral right here is the square root of 2 pi. And then in the middle here, we have 0. Because this integral, the integral z times e to the negative 1/2 z squared is 0. And then this last integral is 1. And so we end up with sigma squared plus mu squared. And so this is the expected value of x squared. And so in summary, the variance of x is the expected value of x squared minus the expected value of x squared. So we get sigma squared plus mu squared minus mu squared, which is sigma squared.